Alright guys, so today we're going to talk about pedigree charts, and these are like a family tree that we're able to see the genetics in. So instead of just looking at names of individuals, we're more concerned about the genotypes and phenotypes of the individuals. So it shows the relationship in a family, and we use it to show the inheritance of a particular trait. We're usually looking at one thing. Sometimes it can be a disease, it can be um, handedness, it could be whatever the subject of the pedigree is looking at. It's looking at one trait though. It's used to show genotypes and possible phenotypes of family members. They can be autosomal, meaning they're carried on any of the chromosomes in the body 1 through 23, or it can be sex-linked, which is chromosome number 23. So that's our 23rd pair of chromosomes is the X and the Y, or the sex-linked traits. So if the allele is carried on the sex chromosome, then it is considered a sex-linked pedigree. Scientists or genetic counselors, they can also sometimes find out about your family tree and make a chart to analyze it. So like say you have like Huntington's disease in your family, you might want to go to a genetic counselor and they would do a pedigree and they would analyze it. You might want to know your chances of having a child that has muscular dystrophy or some other illness to make decisions about planning for the future. So scientists would find out who had the disease in the mother's or the father's families, and then they would use that information to calculate the probability of the couple having a child with the illness. All right, so to construct a pedigree, first you need to know the pieces and parts. So a circle is going to always represent a female, and a square is always going to represent a male. This is a sample of a pedigree, and this would be a really good thing to write down and make sure you know so that you can study this. But basically, all of the circles are girls, all of the squares are boys, and then some of them are filled in here. Filled in means they have or express the trait. We tend to call them affected, meaning they have the trait. We say affected because many times when we're doing pedigrees, we're really talking about a disease, so we say they're affected with a disease. A half shaded in means that they are a carrier. They're heterozygous. They have one of the genes for the disorder, but they have one normal gene for the disorder. Okay. Then you have a series of these lines, and basically you have these lines between these two individuals, and that line between them means that they are married. And then you have a line coming down from the mating line, and then you have all of these ones coming down from that line. So basically this couple had children, and I'm going to get a pen here so that I can circle what I'm talking about. But basically, this individual here, this individual, this individual, and this one was are the offspring of this parent set. Okay, so this female and this male mated 1, 2, 3, 4 times. It resulted in offspring. They had 2 female offspring and 2 male offspring. One of their female offspring was a carrier. The one of them was unaffected. So if they're completely, not colored in or anything, that means they are homozygous for the normal characteristic. If they're completely shaded in, like this one here, this individual was affected by the disease, this male here, and then this male was unaffected. And then what happens here now is that the children, this daughter, got married, or became a mating partner with this male, and then they had 3 offspring. Okay, so you have offspring coming down from the mating line here. Okay, so if we look at this, there's also a way to do fraternal twins. So if you have a twin, instead of having a line like this for twins, which was what you would do for normal offspring, the twin line is kind of just a V coming down from the same thing. And if they're identical twins, you connect them then between the middle. That shows that they're identical twins. Okay. A line between the two is traditionally it was called a marriage line. It's just a mating line, right? You don't have to be married to mate. So these individuals are mating, and then from there the line drops down. These are all their offspring, and so these ones are siblings of each other. This guy is this girl's brother, and so on. Okay, so let's look at an example here. What does this pedigree look like? Well, it's basically like a family tree, right? You have grandma and grandpa, and then you have all of maybe this is your mom, and then this is your other grandma and grandpa from your dad's side. They had your dad, and then mom and dad made you and your other brother. Okay, so it's basically like a family tree, and that's because that's exactly what it is. But when you dig down into it, it would start coloring them in to show you a particular kind of trait. So basically, you're going to determine if the pedigree chart shows an autosomal or X-linked disease. X-linked means that they're linked to the sex genes, the one pair of sex genes that you have, or autosomal means that those genes can be on any of the other 22 chromosomes. If most of the males in the pedigree are affected, then you're going to look at it and say it's X-linked. Okay, you would see mostly males affected. If it's about 50-50 ratio between men and women, you'd say it was autosomal. Okay, if the disorder is X-linked, most of the males will have the disorder because you got to remember that the Y chromosome cannot mask the effects of an affected X. That's why most of the men have a sex-linked trait. A female can have the disorder, but it would be a very low percentage. For a female to be affected, she would have to have had to receive an affected gene from her mother and her father. That means that the father would also have the disorder, and the mother was a carrier. Okay, so if we look at this trait here, this tree, is it autosomal or X-linked? Okay, go back to what we said here. If most of the males in the pedigree are affected, it's X-linked. But if it's about 50-50, it's going to be autosomal. So if we look here, we got 1, 2, 3 males and 1, 2, 3 females, which is about 50-50. So this pedigree is autosomal, right? Because we have about a 50-50 mix between males and females. 3 men have it, 3 women have it, so it is probably autosomal. Okay. The other thing is you want to determine whether or not the disorder is dominant or recessive. If the disorder is dominant, one of the parents must have the disorder. And if the disorder is recessive, neither parent has to have the disorder because they can be heterozygous. For example, Huntington's disease is a dominant disorder. So if you have only one dominant gene, you will have Huntington's disease, which is a lethal disorder. And so that does not show up until the person is in their middle ages, around 45 or so. It will quickly decrease their motor skills and their brain will begin to deteriorate. And if a disorder is dominant like that, one parent must have the disorder, either homozygous dominant or heterozygous recessive. Both parents do not have to have the disorder. One parent might not have the disorder or be a carrier. If a disease is dominant, it does not skip a generation unless one parent is heterozygous dominant and the other parent is homozygous recessive. In this case, the child has a chance of not receiving the dominant gene. If the disorder is recessive, a parent does not have to have the disorder but could still pass it on to their offspring. Okay, so we're basically looking at the parents. Does the parents have the disorder? If that's the case, it's probably dominant. And if most of the parents don't have the disorder, then it is probably going to be recessive. So let's look at this one, for example. Do you think this is dominant or recessive? Well, if you look at all of the parents of the offsprings that are affected, well, this one's affected, well, so is their father. This one's affected, so is the mother. This one's affected, so is the father. So since most of the parents have the disease also, this would be considered a dominant pedigree because it didn't skip a generation. All of the parents in each generation, like this would be considered generation one, generation two, generation three. Each generation then has somebody affected, so it is a dominant trait. What about this one? Is this pedigree dominant or recessive? Well, if you look at this organism here, they have the trait, but their parents do not. And again, same thing here. They have the trait, but their parents do not. So that indicates that it is, in fact, recessive because these guys must have been carriers. They have one of the genes, but they are not exhibiting it. Okay, so now we are going to practice creating some pedigrees. And these can be fun. They're kind of like a puzzle to solve because they don't just straight up tell you how to draw it. It's going to say things like, well, this couple had 3 children and one of their daughters married a guy like this and they had this many children. So it's kind of like solving a problem or a little like one of those critical thinking puzzles. So don't get frustrated. Use an eraser, erase if you have to, and try again. All right, guys, take care.